Now we're going to look at solving absolute value equations. So we know that for an absolute value, if I have the absolute value of x, then it's going to be the positive version if x is greater than 0, or the negative version if x is less than 0. So the first thing I'm going to do is I'm going to isolate the absolute value. Then I'm going to consider the two possible cases. One is going to be the positive version, one is going to be the negative version of the absolute value. So the expression of the inside absolute value is positive, or 0, or the expression inside is going to be the negative version. So I'm going to split up into case 1, case 2. Then I'm going to solve for x in both cases individually, and then for part 4, I need to verify that the solutions actually work. Because remember, if I'm doing this, then I could wind up with possibilities where it's accounting for things that don't actually work in my equation. So I can do that by subbing into the value of x for the original equation just to check and see if it actually does balance out. There is always the possibility of having extraneous roots like we saw with those radical equations. So if I am solving the first one algebraically, I'm going to split it up into case 1 and case 2. So I have case 1 is going to be where 6 minus x is equal to 2. I'm going to have case 2 is going to be where the negative of 6 minus x is equal to 2. Here's my positive one, here's my negative one. So if that's true, then I can state that 6 minus x is equal to 2, or negative x is equal to negative 4, x is equal to 4. For the second case, I'm going to state that negative 6 plus x is equal to 2. And when I move the negative 6 over, I get x is equal to 8. Now I'm going to check in both cases and see if they work. So if I have the absolute value of 6 minus 4, does that actually equal 2? Well, the absolute value of 6 minus 4 is going to be 2, and the absolute value of 2 does equal 2, and that solution works. Or if I have the absolute value of 6 minus 8, does that equal 2? Well, the absolute value of 6 minus 8 is going to be negative 2, and the absolute value of negative 2 is positive 2, and that one works as well. For example B, I need to start by isolating the absolute value. So I'm going to say the absolute value of 4x minus 5 is equal to, when I move that, 9 over negative 7. Now, when I'm solving this, I'm going to split it off into the two possibilities. So I'm going to have case 1 is going to be the positive version. 4x minus 5 is equal to negative 7. And case 2 is going to be the negative version. Negative 4x minus 5 is equal to negative 7. So if 4x minus 5 is equal to negative 7, then 4x is going to equal, when I add 5 to both sides, negative 2, or x is going to equal negative 1 over 2. On the right-hand side, if I have negative 4x plus 5 is equal to negative 7, then negative 4x is going to equal negative 12, or x is going to equal positive 3. Now I need to test these possibilities. So I'm going to state that for the first one, if I have the absolute value of 4 times negative 1 over 2, minus 5 plus 9 is equal to 2. The absolute value of negative 2 minus 5 plus 9 is equal to 2. The absolute value of negative 7 plus 9 is equal to 2. Or, in this case, 7 plus 9 is equal to 2. Well, we know 16 does not equal 2. There's an extraneous root. In the second case, if I have 4 times 3 minus 5 plus 9 is equal to 2, 12 minus 5 plus 9 is equal to 2, or absolute value of 7 plus 9 is equal to 2. 7 plus 9, once again, does not equal 2, or 16 does not equal 2. There's another extraneous root. In this case, neither of the solutions that we got worked. Why was that the case? Well, we already know that the absolute value of a number is going to be the positive version. So if I take the absolute value of 4x minus 5 is equal to negative 7, that's never going to happen. So this one actually has no solution that is going to work. All right, and taking a look at case C. Well, it's already isolated, so I'm going to say for case 1, I would have positive x plus 5 is equal to 4x minus 1. And for case 2, I'm going to say that the negative of x plus 5 is going to equal 4x minus 1. This is going to give me x plus 5 is equal to 4x minus 1. Or when I move the x to the left, I have negative 3x's is equal to, when I move the 5 to the right, negative 6. And x is going to equal 2. In this case, I'm going to say that negative x minus 5 is equal to 4x minus 1. Or negative 5x is going to equal positive 4. X is equal to negative 4 over 5. And now I got to check both the cases. Well, if I say that the absolute value of 2 plus 5 is equal to 4 times 2 minus 1, then the absolute value of 2 plus 5 is going to be 7, is equal to 4 times 2 is 8 minus 1, 7 equals 7, and this solution does work. For the second one, if I said that I had the absolute value of negative 4 over 5 plus 5 is equal to 4 times negative 4 over 5 minus 1, then negative 4 over 5 plus 5 is going to leave me with positive 21 over 5. And 4 times negative 4 over 5 is going to be negative 16 over 5 minus 1. Well, I'm going to have to change that 1 to negative 5 over 5 to combine them. And I get 21 over 5 is equal to negative 21 over 5. That is not true, which means that this is my extraneous root. So in this case, I only have one solution that works when x is equal to 2. So I can see that I can have a couple of possibilities. I can have two solutions, like in example A. I can have no solutions that work, like example B. Or I can have one solution that works, like in example C.